Get ready because NASA, in collaboration with IBM, has unveiled a groundbreaking AI model that could revolutionize our understanding of the Sun. The newly introduced Surya heliophysics foundational model promises to unlock secrets about solar dynamics like never before. However, there's some twist worth noting. The information initially stated that this model utilized 14 years of data from the Solar Dynamics Observatory, but the truth is, it was actually trained on 9 years of data and achieved an impressive 16% improvement over existing benchmarks. The challenge of comprehensively understanding solar events has intrigued scientists for years. By utilizing Surya, scientists can better forecast how fluctuations in the sun's ultraviolet radiation influence Earth's upper atmosphere, potentially providing vital early warnings for satellite operations. Early assessments indicate that Surya is making significant progress in the realm of solar flare forecasting, an area that has remained a tough nut to crack in heliophysics. Surya marks a crucial milestone by enabling visual predictions of solar flares up to 2 hours ahead of time. This achievement not only underscores the potential for AI applications in predicting space weather, but also outperforms previous benchmarks by 16%. NASA is committed to transparency, so they are making the model available for enthusiasts and researchers alike on platforms such as Hugging Face and GitHub, encouraging the broader community to innovate based on the vast and consistent datasets provided by the Solar Dynamics Observatory. Surya's success hinges greatly on the Solar Dynamics Observatory's comprehensive long-term data collection. Launched in 2010, this observatory has compiled a robust dataset featuring high-resolution images taken every 12 seconds across multiple wavelengths, in addition to precise measurements of solar magnetic fields. This well-defined and stable dataset, which encompasses a complete solar cycle, sets the perfect stage for AI models like Surya to uncover subtle behaviors in solar activity that might otherwise go unnoticed with shorter datasets. What sets Surya apart is its foundation model architecture, which enables it to learn directly from raw solar data, without the need for extensive labeling, a common requirement for traditional AI systems. Its versatility opens doors to a multitude of applications, which include monitoring active solar regions, predicting flare activities, forecasting solar wind speeds, and even integrating data from other significant observatories, like NASA ESA's Solar and Heliospheric Observatory and NASA's Parker Solar Probe. Kevin Murphy, the Chief Science Data Officer at NASA headquarters, emphasized the importance of this development by stating, "We are advancing data-driven science by embedding NASA's deep scientific expertise into cutting-edge AI models. With a foundation model trained on heliophysics data, we can analyze the complexities of solar behavior with unprecedented speed and accuracy." This model not only enhances our understanding, but also highlights how solar activity has far-reaching implications for vital systems that we rely on daily here on Earth. The impact of solar storms on our technology-reliant society cannot be understated. Intense solar events can invigorate Earth's ionosphere, leading to erroneous GPS signals or complete interruptions in satellite communications. Power grids are not immune either. Geomagnetically induced currents from coronal mass ejections can overburden transformers, leading to extensive outages. In commercial aviation, solar flares can interfere with radio communications and navigation systems, while high-altitude flights become exposed to amplified radiation. For astronauts on missions to the Moon or Mars, accurate forecasting of solar events becomes critical in ensuring their safety from potentially dangerous radiation spikes during solar particle events. The effects of the sun reach far and wide, even concerning the increasing number of low Earth orbit satellites, tasked with providing global high-speed internet. When solar activity intensifies, it heats up Earth's upper atmosphere, causing increased drag on these satellites, which can disrupt their orbits and even lead to premature re-entry. Satellite operators face a constant struggle to predict when and how solar flares might impact the functioning of these satellites. Joseph Westlake, director of the Heliophysics Division at NASA headquarters, remarked, Our society is built on technologies that are highly susceptible to space weather. Just as we use meteorology to predict Earth's weather, space weather forecasts provide insights into conditions and events in the extraterrestrial environment that could significantly affect our technologies and daily lives. Harnessing AI with data from our heliophysics missions is essential for bolstering our space weather defenses, protecting astronauts, spacecraft, power grids, GPS systems, and countless other essentials we depend on. Although Surya is specifically focused on solar studies, its structure and methods have applicabilities that extend to various scientific fields, whether in planetary science or Earth observation. Surya is paving the way for similar AI-driven research initiatives across diverse disciplines. Surya is part of a larger NASA initiative aimed at creating open-access tools powered by AI for scientific inquiry. The model and its training datasets are being made freely available online, allowing researchers, educators, and students worldwide to overcome barriers and explore novel discoveries. The successful training of Surya was partially backed by the National Artificial Intelligence Research Resource, NIR pilot, an initiative led by the National Science Foundation, NSF, that grants researchers access to advanced computational resources, expansive datasets, and AI tools. The NIR pilot effectively brings together federal and industry resources, such as cutting-edge computing power from NVIDIA, to increase accessibility to the necessary infrastructure for pioneering AI research. Katie Antipas, director of NSF's Office of Advanced Cyber Infrastructure, noted, "This project exemplifies how the NIR pilot is consolidating federal and industry AI resources to catalyze scientific innovation." With the support of NVIDIA and NSF, we are not only enhancing present-day research, but also laying the groundwork for a national AI network that will drive future discoveries. Surya is a testament to a concerted effort spearheaded and backed by NASA's Office of the Chief Science Data Officer and the Heliophysics Division in partnership with the NSF and various universities, aiming to advance NASA's scientific missions through state-of-the-art data science and AI models. The model's architecture has been collaboratively developed by the Interagency Implementation and Advanced Concepts Team, IMPACT, at NASA's Marshall Space Flight Center, in conjunction with IBM and a dedicated science team. This science team, put together by NASA headquarters, consists of experts from various esteemed institutions, such as the Southwest Research Institute, Texas, the University of Alabama in Huntsville, the University of Colorado Boulder, Georgia State University, Princeton University, and several branches of NASA. For a deeper dive into the inner workings of Surya's architecture, its collaborations with industry and academia, and the hurdles faced during its development, be sure to check out the blog post on NASA's Science Data Portal. Discover more about NASA's vision regarding foundation models for scientific research by visiting their dedicated page.